Vamos a darle inicio al seminario del día de hoy. Está con nosotros Juan Manuel Frausto, que viene del Fondo Mexicano de la Conservación de la Naturaleza, y el doctor Boone Kauffman, quien va a dar la plática, y Vanessa Valdés, que también es parte del programa Cambio Climático. Bueno, Juan Manuel Frausto es director del programa de conservación de bosques, cuencas, del Fondo Mexicano para la Conservación de la Naturaleza. Entonces, él nos va a presentar la labor que ha hecho el doctor Kauffman para introducirlo y que después de su presentación.
Bueno, diré la labor del doctor de los últimos 12 días, ¿verdad? Porque lo otro se resultaría un poco largo. Bueno, lo que quería es darles un antecedente de por qué está aquí Boone, por qué estamos... Hola, Carlos, ¿cómo estás? ¿Por qué está aquí Boone y por qué estamos nosotros? Desde el año de 98 venimos trabajando con el Servicio Forestal de Estados Unidos en materia de incendios. Con ellos trabajamos un programa de protección contra incendios que terminó en el 2004. A partir del 2005 ampliamos la cooperación técnica internacional y bueno, hemos recibido por parte de ellos la identificación de ser su in-country partner en la cooperación técnica, y esto nos ha permitido venir trabajando distintos temas a lo largo de estos últimos 5 años. Entre ellos nos ha tocado salud forestal, cuestiones de sistemas que relacionan protección contra incendios y cuestiones económicas. Y ya en los años más recientes nos hemos metido, obviamente, como ha sucedido en muchas áreas, a la cuestión de cambio climático. La agenda que establece esta cooperación técnica está definida en una buena parte por las prioridades del gobierno de los Estados Unidos de América y por las prioridades de las autoridades del gobierno de México, en este caso CONABIO y CONAFOR. Lo que hemos venido trabajando ya el año pasado, estuvo con nosotros haciendo un inventario de combustibles en la reserva de la biosfera de Siancán, y este año estamos trabajando un desarrollo de capacidades en ecuaciones alométricas. Un grupo de México se acaba de ir a Princeton para tomar este taller y tratar de adaptar las ecuaciones acá a México. Recién estamos por terminar el establecimiento de 2 torres de flujo de carbono, una en la península de Yucatán con el Centro de Investigaciones Científicas de Yucatán, la otra en el estado de Hidalgo con el Colegio de Postgraduados. Estas están en áreas forestales prácticamente. Y el otro asunto es la determinación de existencias de carbono con un método que está trabajando el doctor Kauffman. Entonces esta es como la gran película de lo que estamos haciendo y de lo que hemos venido haciendo. El interés de Boone es traer una metodología que está trabajando en el marco de un proyecto global sobre manglares que él les comentará un poco más tarde. Y la idea, como lo hemos trabajado en el Fondo Mexicano, es tratar de consolidar las capacidades de los grupos mexicanos, sean estos gubernamentales, de organizaciones civiles o incluso de organizaciones académicas, para fin de tener acceso a información, a conocimiento que nos permita hacer mejor las cosas. Ese es el escenario en el que estamos trabajando. La idea es, bueno, aprovechar también la experiencia del doctor Kauffman para que comparta con ustedes lo que está haciendo y si es factible y conveniente para las partes, pues tratar de establecer acciones posteriores en este marco de cooperación. Le agradezco a la CONABIO que nos haya recibido y me da mucho gusto regresar a estas instalaciones que son de mucho cariño para los que vivimos en este país y un orgullo también. Le doy la bienvenida al doctor Boone Kauffman. Él es experto del Servicio Forestal de los Estados Unidos, ha trabajado en distintas partes en su país, mucho trabajo en Asia con la parte de los manglares, y viene a establecer los primeros sitios de esta metodología en Latinoamérica. Hace rato tratamos de hacer una gestión corta con las agencias de los Estados Unidos para el Desarrollo Internacional, a ver si el año que entra podemos apoyar el establecimiento ya de una torre de flujo en manglar, que sería la segunda en el mundo. Entonces vamos a ver si esto resulta. Boone, bienvenido y muchas gracias.
Muchas gracias por la oportunidad de hablar con ustedes hoy. Infelizmente yo estoy un poco cansado. Si es posible, ¿puedo dar en inglés? ¿Todo el mundo me entiende? No. Okay. Entonces, si yo puedo hablar esto, yo necesito hablar una cosa. Un amigo, yo tengo mucho trabajo aquí en México y también en Brasil, y 10 años más o menos. Mi colega en Brasil, Alberto Setzer, me pregunta un día, ¿cómo se llama de un hombre que se puede hablar 2 lenguas? Y no sé, es un bilingüal. ¿Y cómo se llama la gente que se hablan 3 lenguas? No sé, trilingual, sí. ¿Y cómo se llama un hombre que se puede solamente una lengua? No sé, dices, una gringo. Entonces, sí es posible. Me disculpe, pero la mayoría de esta presentación se van en inglés. Y más rápido también. Pero yo soy un biólogo, no soy ingeniero, no sé. How do you get this thing to work? Aquí. Los bosques tropicales, vamos a comenzar en una manera muy general. Cuando yo tengo un diapositivo en español, me voy a dar en español, hablar en español. Ok, aquí. Sí. ¿Oh, sí? No está funcionando. Aquí. Los bosques tropicales, todo el mundo conoce esto. Cubren aproximadamente solamente 10% de la superficie terrestre de la Tierra. Alcanzar alrededor de 4% de la carbono en la vegetación terrestre en todo el mundo. Por eso son muy importantes como un banco de carbono. Y son grandes sumideros y las fuentes de carbono global. Deforestación se contribuye entre 3.5 pentagramas de carbono en la atmósfera por causa de deforestación, y también las acumulaciones de carbono desde fotosíntesis es entre 1 a 2 pentagramas cada año. La cosa interesante es un gran nivel de uncertainty. That means go. Y puerto entre la mitad de 2 a terceros, la mitad a 2 terceros de las especies en el mundo. Oh, you got to turn it on. What do I feel stupid now? Okay. Y proporcionan muchos servicios de la que eso es horrible manera de comenzar una práctica en un otro país. Proporcionar muchos servicios de los ecosistemas vitales para la humedad y finalmente pequeños cambios en bioma bosque tropical puede potencialmente conducir un gran impacto para la biodiversidad y el cambio global. Y yo principalmente voy a hablar sobre los humedales del mundo, como los manglares. Aquí está un manglar en Borneo. Pero quiero comenzar más general. ¿Cómo es el valor de los humedales en todo el mundo? Esto es el Pantanal de Brasil y también en muchos de los humedales del mundo, como yo estoy trabajando en Borneo, hay muchos animales carismáticos, como este orangután estaba en una de mis parcelas y depositó algunas urina en mi mochila, pero es muy, muy magnífico. También en Brasil, otros lugares, los tapirs, habitantes de los humedales. A veces, esto es muy irónico. Esto es un culebra grande, un culebra sucuri, se mató por un logging truck en el Amazonas. Y otra cosa triste de Brasil, esto es el símbolo de Brasil, el guarazuba, y ya está casi extinto en las florestas por causa de deforestación. También aquí en México, usted tiene una de las flores, los aves más bonitas en todo el mundo, en las áreas de Celestún, y también los manglares es muy importante, los vinícolas entre los ecosistemas es importante. Otros animales bonitos como este eyelash palm viper de Costa Rica. Y las cosas muy interesantes de los usos de tierra en el mundo. Esto es un leaf mimic de tamaño como mi mano. Y esto estaba en una parcela de mío en Amazonas. En esta floresta hay solamente 2 o 3. Esto es el forma de este animal es igual exactamente de un bejuco, a vine, en la selva. Y este bejuco tiene una densidad de solamente 1 o 2 cada hectárea. Y con deforestación, desmatamiento, se perdemos estos bejucos. Y después de la recuperación, no hay este bejuco. Si no hay este bejuco, no hay este insectivos. Y este pattern is repeated so many times with deforestation in the Amazon. Much as you learn about working in biology, también es importante hablar with the people to learn what they know, what they think. These are many people that I work with from the tribal Baré in northern Amazonas, which they taught me much. These are borracheros, rubber tappers from Amazonas. You can see they're wearing rubber boots, natural rubber boots. They'd never seen a car. They're about 70 miles from Porto Velho, but they knew a lot about the forest. They knew much about the forest, much that we could learn from the forest and means of how to manage the forest, how to sustain the resources in the forest. And this is a very interesting lugar. You think this is Guatemala, huh? Looks like Guatemala. These are the hamong, flower hamong de flores. People on the border of China and northern Vietnam. Now, they've lived in this area for many thousands of years, but you see very many interesting patterns repeating itself across the world as well. And this is another interesting, these are 5 widows, 5 viudas de Bangladesh, el área de Sundarbans, el manglar más grande en todo el mundo. Y también la densidad más alta de tigres en todo el mundo. Estas 5 viudas, todas las esposas se marido por causa de un tigre. Y ellos no están preguntando para la destrucción de los tigres. Quieres una mejor manera para vivir, mejor oportunidades en el mundo. Es muy impresionante. También la mayoría de mi trabajo es en áreas de los humedales, en muchos lugares. Y podemos conocer muchos en otras áreas del mundo, como las cuencas en Estados Unidos. Esto es la montaña más alta en el Estados Unidos, Mount Whitney en California, con muchas cuencas, muchos humedales pequeños en los ríos. Hay también muchos humedales en áreas con áreas altas y esto tiene muchos materiales orgánicos en estos suelos también, como en los manglares aquí. Aquí están otras áreas humedales muy interesantes. Es el Río Grande Ronde River, es casi 60 miles arriba del boca del río Cascades. Y esto es una área de reproducción muy importante por los salmos. Y a veces en este río se puede encontrar salmo de más de 20 kilos en tamaño, reproduciendo. Pero esta especie es en peligro de extinción por causa de many dams on the river, uso de tierra, principally livestock grazing, many other factors. So, these sorts of relationships we're working on. También en las áreas como México, cuando hay desiertos, muchos de las montañas, como en los Steens Mountains en Oregon, hay muchos ríos con una biodiversidad muy distinto para estos ríos. Este tiene algunas truchas, viven solamente en este río pequeño. Y otros desiertos están siempre, los ríos y los humedales están siempre importantes. Aquí están algunos datos de mi estado, Oregon, y estados de Washington, cómo es la diversidad, el valor de la diversidad en los humedales de Estados Unidos. Es igual aquí, ¿no? Pero de todas las especies de estos 2 estados, es 573 especies, más de 70% dependen en los humedales, las áreas de riparia, la mayoría de los aves, los mamíferos y los anfibios y reptiles. Entonces, en todo el mundo, humedales es muy importante por biodiversidad. Y también en las áreas como el Arctic National Wildlife Refuge, los humedales es importante por la biodiversidad allí también. Y también es un muy grande peligro de extinción por causa del desarrollo del petróleo en este lugar. Y esto no es nuevo para ustedes. Creo que todos de ustedes acredito esto or believe this. But in the United States, there's a lot of politicians that choose to ignore science. And so it's so often we have to remind our politicians that warming of the climate is unequivocal in terms of science. You know, it's just a certainty. And observations of increases in air and ocean temperatures, rises in sea level, increases in intensities of tropical storms, widespread melting, unprecedented rates of melting of snow and ice on the Greenland ice sheet and the Antarctic ice sheet for the first time in the last few years is unprecedented. And of course, it is this is the International Panel of Climate Change quotes. International Panel of Climate Change is very conservative, very safe. When they say stuff like this, it is, you know, basically a consensus. So it's very likely that these increases in man-made greenhouse gases have caused most of the change in the climate. Climate change, as biologists, we all recognize, is an environmental problem. It's a huge, probably the greatest problem facing future generations, particularly those who want to preserve biodiversity in the world. It's also a very large technical challenge. How do we adapt to climate change and preserve things such as biodiversity? And finally, it's a strong moral issue as well. You know, if we look at global climate change, some of the barriers to restoration, to recovery, to adaptation will be the fact that climate change will increase poverty, will increase climate refugees, increase environmental degradation, and probably exacerbate ineffective leadership of our politicians. It's also important to look at the relations with climate change and land use change, because really to date, land use change, deforestation, coastal development, etc., is a bigger problem really than global climate change in terms of affecting biodiversity. You know, this is what we can find when we work in the rainforest of Borneo, for example, the sun bears being poached still, shark fins still being for sale, widespread deforestation, loss of habitat for orangutans. So I want to kind of talk a little briefly then about climate change and how my research and my colleagues here in Mexico and other places in the world are looking at climate change and what aspects of climate change we're looking at. We know that these are the sources, los fuentes de climate change, fossil fuels, the dominant, but also other sources like cement factories, and land use and land cover change. All of these are creating changes in the climate. This is what we have a great deal of certainty. We know that temperature of the ocean, temperature of the air is rising. Many, many states in the United States last month had the hottest month on record. Fortunately, it was where a lot of the most conservative politicians live who don't believe in climate change, too. But greater and more frequent and more intense El Nino events, greater frequencies of tropical storms, hurricanes, tropical cyclones. All of these we have a great deal of certainty on. What we have less certainty on is how much, what are the sources of greenhouse gases still? It's really, we know how much exactly through global records of the refineries, how much oil is going into the atmosphere, almost to the ton. Where the great uncertainty still rises is from land use, land cover change. It's a huge range, 1 to 3 pentagrams. So that's about maybe between 14 and 32% of the CO2 that goes to the atmosphere comes from land use, land cover change, probably more at the lower end, because not that land use, land cover change is decreasing, but that fossil fuel use continues to increase. So the next thing is that how will the ecosystems respond to climate change? This is where we have less certainty. You know, we don't know how the biodiversity is going to change, how invasive species are going to change, how might fire regimes change, nutrient cycles change. All of these have a relative low degree of certainty. It's a very, very important area for research in the future. And also, what we have less understanding is how might these shifts feed back and actually accelerate global climate change. For example, if we start to lose mangroves, we start to lose how much of that carbon will go to the atmosphere. If we start to lose forest with fire, how much of that will increase the CO2 in the atmosphere. So this brings us then to other areas that we're working on. Is how can we start to slow this rate of change through better land management, through better protection of resources. And this is what I'm going to talk about a lot today. We see many things such as cap and trade, RED, reduced emissions from deforestation, degradation, a means to finance the protection of forest for the first time. This was presented first at the Bali Roadmap, one of the UNFCCC meetings about 4 years ago, further developed at the Copenhagen Climate Change, and then finally last year in Cancun, RED was accepted at the meeting in Cancun. So finally we see then how will, with changes in ecosystem structure, how will we adapt to this? How will we adapt to preserve the biodiversity? And what we find quite often is that the best mitigation, which is usually preserving the intact ecosystems, is also the best adaptation, because the most healthy ecosystems, the most intact ecosystems are those that are most buffered to climate change. And finally, the hope, of course, would be sustainable land use, sustainable management, sustainability of the biodiversity of the area. So with all of this then, what might be some of those responses that were blue? But we know, again, the reason why we have so little understanding is because of these interacting feedbacks. But the fear is with more El Niños, for example, forests start to collapse due to drought. We've noted this in Amazonas and in Borneo both with El Niños, even before the fires come. Usually the fires follow in these areas, greatly exacerbating the loss of these forests, giving us losses in biodiversity. And it might be things that we're not even aware of, the pollinators. Of course, the large animals that can have strong keystone effects or top-down effects. Predators. We might see dominance of invasive species, more and more invasive species invading the areas. This may be plants, maybe insects. We're seeing more diseases spreading throughout the world. And finally, the collapse of coastal forest, such as manglares, due to sea level rise and increased typhoons, hurricanes. And that brings me to my talk. That was a long introduction, but I want to talk then about climate change and land use and wetlands. Let's talk about mangroves. These are tidal wetland forests in the tropical areas of the world. They historically were at least 240,000 kilometers, now much, much lower because of large rates of deforestation and land cover change. They occur in 124 countries, of which Mexico is the 5th largest area for mangroves in the world. And la tasa de deforestación es más alta cualquier tipo de bosque tropical en el mundo, principalmente en las áreas como Indonesia. So, this is a slide. The next two slides were prepared by my postdoc who works in the mangroves. And so he had friends always asking, well, what's it like to work in a mangrove? And there's a great quote from the FAO book. It's a very interesting place, but not where you'd want to go for a picnic. You know, no es un buen lugar para un picnic. Y otro quote is, for a tourist, the place is singularly uninviting, which is not true, but it's a great quote. So he stated, what's it like to work in a mangrove? And it's oppressive heat, muy calor, mucho humidity, huele como caca, like sulfur. You're in waist-deep mud, very slippery ground, and areas with sharp spikes. This is Sonoridia from Micronesia. This is, incidentally, this is my son working with me. This is tangled aerial roots to climb through, mucho mosquito, muchos culebras venenosas, muchas culebras de mar venenosas. Y en este año, en México, ahora tenemos rayas en nuestras parcelas también, en los chaparros de Siancán. Y sea urchins. In Bangladesh, we have tigers and crocodiles that can eat you, and you have to work fast in the tides, or you may spend the night in the mangrove. En los manglos, pues es una serie de servicios de los ecosistemas de gran valor, como biodiversidad, calidad de agua, la mitigación de las inundaciones, protección litoral de las tormentas tropicales, pescados, crustáceos, madera, protección y, más importante, vínculos a los ecosistemas marinos como pastos marinos, como arrecifes, como cesteros. Y también un valor más o menos nuevo es como sumideros de carbono. Y esto es una gran importancia con respecto a la red, la reducción de la deforestación y la degradación. Otro servicio, ecosistema de los peces, más de 75% de todas las especies comerciales pasan parte de su vida en los manglares, donde se encuentran zonas de cría, abrigo, comida. Y también estos humedales es issues of global concern. In Southeast Asia, this is an aerial photo of Borneo during the fire season. And deforestation in Southeast Asia, tropical forest, is amongst the highest in the world, certainly still higher than Amazonia, for example. And all of these areas in red are fires mostly in humedales de agua dulce durante la época de seca. Y también in áreas como Borneo, they've lost over 50% of their mangroves in the last 20 years. So the annual deforestation rates are as high as 8% in mangroves, and this is principalmente por el desarrollo de granjas de camarones y de pez, and as high as 2% in the humedales de agua dulce. Oops, that's the forest at night, I guess. Okay. Shifts in climate or land uses that result in the shifts of peat forests from sinks to sources of very significant climate discurrent. In other words, all this deforestation is one of the most significant causes of climate change. Some of our early estimates of just the deforestation alone of mangroves, which is not being accounted for in any of the global carbon accounting systems right now, is our predictions are that it's as high as 10% of all the deforestation in the tropics alone. So it's 10% that we're even missing. It's part of that huge range of uncertainty in the forest. And then sea level rises, changes in El Niños, patterns of precipitation and other effects of climate change can disproportionately affect the humedales, both the manglares y también los humedales de agua dulce. So this brings us to what can we do? Where in biology, where in the world of natural resources do we fit in slowing rates of deforestation? And this comes to the relatively new concept of RED, reducing emissions from deforestation. These are basically mechanisms that are using market or financial incentives to reduce emissions of greenhouse gases from deforestation, degradation. Coastal ecosystems, it's very important to think about mangroves and the importance of mangroves, because halting their decline also would generate, through institution, I can't even speak in English, through implementation of RED, improve food security, livelihoods in the coastal zone, the lives of the indigenous people or the people living in the area. And here's just an example, the rationale for using RED to finance, to protect an area. So let's say that we do have a RED credit for a forest conservation project. This is being implemented for the global public good, to slow the rate of climate change. So everybody in the world benefits from this. But we also see that the environment is enhanced through this protection of the forest. Rather than deforesting the area, we now are protecting the area. So we're going to see enhancement or improvement in water quality. We're going to see preservation or improvement in fish habitat. We're going to see protection of biodiversity. All of this, of course, may generate new livelihoods in ecotourism, if we are improving water quality and habitat, we're improving fisheries resources. Particularly, it's very well proven outside the protected areas, fisheries are improved when you have an area protected. All of this then has a social value of improved alternative livelihoods, poverty alleviation, which of course then increases local valuation of the forest. And we're actually seeing some examples of this in Ria Celestún, for example, with the development of ecotourism, and even the recuperación de los manglares. All of this then would lead to greater support for more forest conservation projects, of course, then increasing the global good and environmental enhancement. Esto es en un mundo perfecto. So, why are ecosystems? Porque son los ecosistemas costeros relevantes de algunas estrategias red. Dos razones. Uno, las reservas de carbono es una de las más altas en el mundo, todos los florestas en el mundo, y también es extremadamente vulnerable para la deforestación. So let's talk about these coastal ecosystems. We also call it blue carbon or carbono azul. The ocean's vegetated habitats. And this is mostly mangrove, pastos marinos, tulares or salt marshes or tidal marshes. They only cover less than 1% of the entire oceanic seabed, but account for over 50% and as much as 71% of all carbon storage in ocean sediments, not in the water column, but in ocean sediments. So they're huge carbon pools. They're hugely important. And this also is something that's relatively newly discussed in the world. They are really rapid turnover rates of carbon. They fix a comparable amount of carbon to tropical forest. So these are very, very important. The other reason, of course, again, is between 2 to 7% of these blue carbon sinks, the manglares, the pastos marinos, the pastos, are being lost annually for rice and agricultural and here pasture production, largely for aquaculture. This is the dominant cause. This is in Borneo again. Here, the biggest problems are road development and hydrological disruptions, and of course for coastal development. This is actually a huge pile, almost 15 meters of organic soil that's been scraped off so they can build a large hotel here close to Cancun. Some of the blue carbon sinks we're working on are pastos marinos, tulares de mareas, salt marshes, and principally manglares. But the thing about Mexico that's quite interesting is you have a tremendous diversity, probably more than any other place on earth, in the structure of your mangroves. You go from the forest here to the chaparro here in just a few feet quite often. And this, of course, is great problems for those of us trying to quantify carbon sinks as well as ecosystem structure. And there's a lot of uncertainty that we're working on in these information needs for these tropical wetlands, RED and MRV. We need to know what are the carbon stocks of the intact wetlands. You know, what's the thickness of the peat? Are there potential above ground indicators that we could use remote sensing for? What's the carbon content, bulk density, carbon concentrations? This is what we've been measuring for the last 2 weeks in Siancan. Carbon stocks have degraded. What happens after areas are degraded, after we lose them? What is the dynamics with land use? And then dynamics of carbon accumulation with recovery or with restoration. What are the emissions from the fires in the humedales de agua dulce? Carbon dynamics during land use and abandonment. And just really quickly, where we're working right now, most of our work to date has been in Southeast Asia. Data from 2011, these are the sites we've sampled. In next week we're going to sample, we'll be in Papua next week and in India in November. But most of our work to date has been in Asia, but this year we're expanding this initiative for wetlands is in Africa and Latin America. And of course, this last week was our first time to work in Latin America, where we worked with, in Mexico, establishing 9 permanent plots for climate change, for understanding composition structure of many of the ecosystems of carbono azul aquí in Mexico, 2 parcelas en Manglar Alta, 2 parcelas en Manglar Baja, 3 en Chaparro y 2 en Tular. Ya necesitamos muchos más, 500 más, 50 más parcelas a la mínima en área de Yucatán. Pero es un buen start, buen taller. The challenge that we had in areas like Siancán is this is a mangrove and this is a mangrove. And that's not so easy to use the same methods when you cross the river here. You know, dramatically, nowhere else on Earth have I ever seen this sort of shift in structure in such a small area. And this presented some new challenges on how do we develop the methods to adequately measure carbon stocks or bancos de carbono in these ecosystems. In the forest, we're able to use, a model that we're using, our method, a plot design that we're using throughout the world, where in a transect, usually at the marine ecotone, the ocean, we establish a plot of 125 meters, 7 plots of 7 meters in diameter, where all trees greater than 5 centimeters DAP are measured. The 4 components that we're measuring is above ground tree biomass and carbon stocks, below ground tree biomass, soils, which is very important, and wood. And we measure these in 6 plots, so we get an estimate of ecosystem carbon pools and in 6 locations at every site that we sample. Gives us a good statistical power. Also allows you to return to the site in the future for comparisons as well. Now, the chaparros, completely different structure. Soils are measured the same, but here we had to develop a completely different methodology where still sampling 6 plots, but only in a 50-meter transect, and the plots are half circles of radius of 2 meters. These are densities of individuals of over 50,000 mangrove per hectare. And so these are hugely, incredibly dense sites. Very, very, extremely interesting, I thought. And what a cool ecosystem this is. And so this was we're very satisfied with this methodology. Just some of the examples, the things that we know is very important is the carbon content of the soils. We do see differences in the geomorphology if you're on the coast or if you're on an estuary. These are data, again, from Indonesia, but we see extremely high carbon concentrations in the soil layer. And you notice that it does not shift with depth. It stays very, very high down to at least 1 meter, and then even down to sometimes as deep as 3 meters in riverine and estuarine soil. So huge, this is where the carbon is. Here's just some examples of our results after these measurements. All of these are a different stock or a different pool. Here's the tree carbon, for example, wood carbon, and the rest is soil carbon. This is from Micronesia. This is an example from Kalimantan, Borneo. And you just get an idea of all of this is the soils, about 68%. And the soils here was 83% of the entire Banco de Carbón. So that's where the interest and really the effort needs to lie. Another example is from the island of Yap. These islands are very, very important. They have characteristics which make them especially vulnerable. Many of the areas, the low-lying islands in Micronesia, are experiencing sea level rise such that they can no longer grow crops, where we're seeing the first climate refugees on Earth, really people leaving these islands, moving to other islands, causing quite a bit of social upheaval. Just to look at, in terms of working with Micronesia on developing a RED system, we looked at carbon stocks of the entire island, all the dominant ecosystems. And here's what we find. If you look at the land area, mangroves on this island account for about 12% of the land area, forest about 65%, and savannas or tulars about 23%. But because the carbon stocks are so much greater, and if we look at the soils, you can see here's the soil carbon in the mangrove stays at about 15% for great depths, and then the mineral soils of the upland, much, much lower in carbon and almost no carbon at greater depths. So this gives us then ecosystem carbon pools in the savanna of only about 125, in the upland forest about 400, but in the mangrove almost 1,200 tons of carbon per hectare in the ecosystem. And you see here that this is the amount that's in the forest, the trees above ground, and this is roots and below ground carbon. Again, the vast majority being in these peats. These are largely peat soils that have been accumulating since the last ice age. They're 4,000, 5,000 years old. It's carbon that's very, very old. So one gets an idea too, is if we lose this carbon, we lose it forever. We're not getting it back through regeneration. And anyway, this gives us then, this underscores the value of the mangroves is 12% of the area, but 34% of the carbon pool or the carbon stock for this island nation. Just to give you some more examples, this is IPC, here's some other examples. Here's the IPCC values for tropical savannas, boreal forest, temperate forest, and tropical forest. This is above ground carbon, below ground carbon. These are our data for mangroves in Southeast Asia and data for humedales de agua dulce, peat forest in Micronesia, or in Asia. And you see here that they're 4 to 5 times greater on a per hectare basis, these carbon stocks. So once again, underscoring the potential value. Now, what is also important to note is if we deforest these areas, you know, we lose the above ground carbon, but we also begin to lose the below ground carbon. Typically in areas como Amazonas, como áreas como Los Tuzlas in Veracruz, when we lose the carbon there, we only lose the above ground carbon. The soil carbon tends to be relatively stable, and that's not the case here. So destroying these is a lot more devastating. It results in much higher emissions of CO2 into the atmosphere. Just another example from Mexico. Aquí está datos de Estación Biología de Chamela, bancos de carbón en estas selvas bajas. Aquí está selvas altas de Amazonas y selvas altas de Estación Biología de los Tuzlas. Y también algunos ejemplos de manglares. Y es mucho más alta en esos manglares también. Y it's probable that the tall forest mangroves in Mexico will have carbon stocks. I'll come back in a couple of months and let you know when we get the data analyzed, but this is probably about where we're at. So again, how will climate change affect coastal ecosystems? Why are they so vulnerable? We see changes in temperature, both ocean temperatures as well as air temperature. The increased El Nino events, the droughts affecting fresh water flows into the site, the increased severity of tormentas, tropical storms, hurricanes, increases in sea level, coral bleaching, ocean acidification, all great concern. And what we can see then is sort of this graph of what we can expect. We know that in these small islands and coastal ecosystems, there's strong linkages between the coral reef to the mangrove, to the upland forest. These linkages are rivers, animals, shrimp, fish swimming up and down, dying, bringing nutrients, animals doing the same, people doing the same. And we see all of these impacts, ocean acidification affecting coral reefs, which of course would be linked to mangroves. Sea level rise affecting mangroves and coral reef, intensities affecting the entire cuenca. El Nino events, temperature rises affecting all of this. All of these having results of predicting increases in diseases, plant diseases, animal diseases, human diseases, declines in fisheries resources, losses in infrastructure, roads, houses, airports, industries, all that are on the coast. Losses in biodiversity, declines in human habitability, and decreases in invasive species, basically ecological and cultural collapse. So, while mangroves are adapted to life at the ocean interface, disturbances such as tsunamis, hurricanes, they've evolved with these. They require these in many cases to persist. But they're greatly threatened by land use, land cover change, as well as the results of climate change. And this is where recuperation may be very difficult in the future. Again, this is my son. Another example of sea level rise from Palau. Here's a mangrove moving from seagrass to the seagrass edge. This mangrove is about 328 meters in ancho, and the elevation is about 144 centimeters from the upland edge to the edge of the ocean. And the predictions for sea level rise by the middle of this century might be as high as 1 meter. So we see if we get a sea level rise associated with greater intensities of tropical storms, of hurricanes, then the coastal erosion is a very likely event. And again, the feedbacks of huge losses of carbon from sea level rise, particularly if these areas have been degraded by land use. Again, just gives you an example of, again, along this gradient, we see the seagrass very low, the pastos marinos very low in Bancos de Carbon. And as you get away from the edge, you see higher and higher Bancos de Carbon. So if we see shifts from this level to this, we see huge losses, again, a very negative feedback of climate change. Here are some predictions of sea level with a 1 meter rise in sea levels. The area in red are what predicted to be lost this century. We see this is perhaps one of the largest mangroves in the world in Papua that'll be lost with sea level rise. This is the Mekong Delta, almost 20 million people living there, certainly threatened with becoming environmental refugees. Also one of the most productive agricultural areas on Earth. We can look at areas like Bangladesh, which is one huge delta, and about 112 million, actually more like 150 million today. And as sea level rises, the latest predictions, from IPCC, is by the middle of the century, as many as 35 million climate refugees by sea level rise and by the loss of these areas. So huge social ramifications as well. My colleagues in geology, coastal zone geology, say with the greater storm surges, greater hurricanes, we'll see beaches eroding, ecosystems being lost. So very, very large concerns, very many areas for action now and in the future, I think. And with that, I'll rest. I just want to say this is the group that I worked with the last 2 weeks at CNCon, particularly Fernanda Adami from Zimbabwe. Very great group of scientists and colleagues to work with. Very nice honor for me to work here. And with that, thanks a lot. Any questions, I'll be happy to answer in cualquier lengua.
Yes. Several questions. Are you happy to accept them in Spanish, or would you prefer them in English?
Why don't you do it? You speak English so well.
So, firstly, a couple of comments. I'm not sure if you're aware that you've been preaching to a choir.
Yeah, no, I figured that, you know.
Yeah,
it's so rare sometimes.
Firstly, you might know that CONABIO has been the leading agency in developing the national mangrove inventory here.
Yes.
At more than 50,000 scale. You probably might know also that CONABIO has been in the lead role together with CONAFOR to implement the RED MRV strategy.
Mm-hmm.
So, connected to that, a couple of questions. One of the main problems here in Mexico is actually estimating not only the above ground biomass in mangroves, particularly in mangroves, but also the below ground biomass.
Right.
And recently we had quite an open dispute with the people who've been so far producing the calculations, the allometric calculations, and the only probably know them, based on the forest inventory. The forest inventory has the problem that it is by no means sufficiently dense in the mangrove to actually deliver lots of points.
Yeah.
So we've been discussing with CONAFOR how we could increase these points based precisely on the mangrove inventory we've elaborated. The question would be, I wasn't aware so far, not even from the discussions with CONABIO, that actually the delta between the above ground and the below ground biomass in mangroves is so rich, and it is probably therefore necessary to host the mangroves as one of the main red MRD strategies or red MRD monitoring sites. Could you give us an estimate how many sites, given the by you mentioned heterogeneity in structure, how many sites we would actually need to really be able to cover an estimate and start reporting in red based on these?
Very good question.
Sorry.
No, it's a great question. It's a great thing to discuss. You know, it's like there's several ways. You know, obviously in the mangrove, the mangroves should be stratified from upland forest because they are. The carbon stocks are so dramatically different. What works in the upland doesn't really work in the mangrove. You know, you really need to know below ground carbon stocks because they're vulnerable. They're really vulnerable to land use, land cover change, so you need to know that. You know, my advice for like areas like Yucatan, where you have chaparro, mangle arte, mangle bajo, mangle medio, is to stratify. You can do that through remote sensing, stratify communities, and then from there determine the minimum number of plots that you're going to need for an inventory for mangrove specifically. And then, you know, it's probably not as many as you might expect. I mean, again, we need to get a better idea of the variability in, say, chaparro, maybe 20 to 50 plots in chaparro, maybe 20 to 50 plots in mangle alto, 20 to 50 in mangle bajo is what I would suggest as a good start. You know, it's doable. You know, we did this in Bangladesh. We did we taught a workshop very similar to this Taller and immediately used it to do, we established 150 plots in the Sundarbans of Bangladesh, which we felt was an adequate plot size for about, you know, 400,000 hectares. But it does require.
Just quickly give you in a nutshell what we are doing right now. We are basing a national monitoring on 5 meter data. That's the plan, basically. Having fully processed 5 meter data every year, land cover change, that will basically be the so-called, how's it called? The emission factors are on one side, and the activity monitoring is covered by that. And then we need to expand basically what is happening on site, and we need to do it on 1 hectare. So that's precisely the challenge. And so far, the Seminario is nicely covering most of the ecosystems. Yeah. But I reckon from your talk and talks I had before with other people that it is definitely a neglected ecosystem in the red strategy.
Yeah. No, you're absolutely right, and it's not unique to Mexico. Now, this is a very similar problem. Probably the least inventoried forest in the world is mangroves. And it's very obvious. It's, you know, you're saying there's no inventories of mangroves here. There's absolutely no inventories in Asia. There's few inventories of forest in Asia and zero of mangroves.
No, probably got the best one worldwide based on remote sensing.
Yeah, right. But it's but there's no ground truthing. Yes. So what's the value? You know, so. Right. So, you know, again, there's part of our work, this initiative that we're undergoing, which is a global initiative, is just to get at least tier 2, 3 numbers for the world of mangroves. But, you know, again, it's good at, what our study is good at a global scale, but not good at a national, regional scale that, you know, you're dealing with. So no, I think that I would highly recommend, you know, that the methodology that we have is based upon, you know, forest inventories. You know, we're using 6 plots in a linear fashion. There's a lot of good reasons that I could argue about why this would be a better inventory than, say, the Mexico inventory for forest or the United States inventory for forest. I argue with them. Yeah, no, it is. Yeah. Well, it's the same. And there's a lot of problems with both of those. It's a lot of problems because they're developed for people who've never worked in the field, and particularly never worked in mangroves, where the linear is so much better. So I would use something very similar. The plot size we know is adequate to capture above ground biomass, very good for capturing remote sensing data. And then, you know, the good news is if stratifying in Brazil may give you a better estimate than many other areas of the world for below ground carbon. But I wouldn't count on it. I would measure the below ground carbon. So You could talk.
Measure below ground carbon
You need
below
at least the first time, and then probably suggest every 10 to 20 years or with land cover change. Because it's vulnerable to losses once these areas are deforested.
Would you be willing to help establish a strategy?
Sure. In fact, we already have written the manual for this, so we hope to translate it into Spanish soon. But no, absolutely, that's very important. This is one of the reasons why I'm here. So that's cool. Any other questions or comments in cualquier lengua? You and then you.
The first issues for ecosystem preservation is decision making between the balance of the preservation of an ecosystem and the decision making of projects that might lead to economic development, but however have to take advantage of some land use in certain places. And for decision making, it's always necessary to have a quantification of the economic value of an ecosystem. Do you know of any effective method in the case of mangroves?
Oh, if you have 15 minutes, I'll give you a great seminar on that. We have I have a seminar called the jumbo carbon footprint of a shrimp. And basically, we've done the economic analysis of the trade-offs of a granjas de camarones and in a red carbon trading scheme. Basically, areas of land use that aren't, mangroves are never going to be very productive in terms of anything other than hotel development. We'll never be able to compete on a carbon market with a hotel development, with Cancun. But for shrimp, for pastos, those sorts of things, basically shrimp lasts anywhere between 3 and 9 years and they're abandoned. And you've lost tremendous quantities of carbon. 100% of the above ground, 50% of the below ground, or 100% of the first 30 centimeters and 30% below that. So our estimates are that basically the value of the average shrimp farm comes out to about $7, equivalent to about $7 of value of CO2 per ton in that ecosystem. That's very cheap on the carbon market. You can get voluntary carbon markets for the values, the ecosystem values of mangroves. And this is why there's a group called the Carbono Azul Scientific Working Group working throughout the world who are trying to evaluate this. There's some great, I can give you there have been economists, probably more economists working on this than ecologists, that I could give you some citations where they've used our carbon numbers for economic analyses. But there's few places on Earth where the numbers really add up to red being very high value in mangroves compared to something like a non-sustainable shrimp farm. Good question. Yes, sorry.
Voy a aprovechar tu habilidad de bilingüe.
Sí, no.
Si es necesario que sea en inglés,
Porteño, Spanglish.
Experiencias, ¿has tenido alguna experiencia en los humedales artificiales?
Así.
Artificial wetlands. Y esto lo pregunto porque hay un gran proyecto para introducir estos humedales artificiales en los diferentes municipios del país que no tienen todavía un sistema de tratamiento de aguas residuales.
Sí.
De tal forma de que esto está diseñado como a 1 metro o 1,5 metros debajo de superficie, de tal forma de que ahí se meten piedras, cierto tipo de granulometría y algunas plantas que se encargan de hacer las funciones del riñón en nosotros, ¿no? El riñón en la naturaleza. Entonces, siento que puede ya diseñarse, ¿no? Ya por diseño la profundidad, de tal manera de que tenga todavía mucho mayor valor.
Sí, sí. Hay pocos estudios sobre eso, sobre los ciclos de carbono. Y 2 o 3 puntos aquí es interesante. Uno es en los humedales artificiales hay grandes emisiones de metano a veces, y eso es una causa. Pero también hay grandes tasas de aumentación de carbón también. En áreas como el sur de Estados Unidos hay muy rapidísimo acumulación de carbono en los suelos. Entonces es difícil determinar los valores. Hay muchos valores para ecosistemas, para la calidad de agua, pero como un banco de carbón ya está desconocido. Depende de muchas cosas, muchos factores. ¿Está bien?
Como banco de carbón está que...
Sí. El banco de carbón, a veces, en áreas como los pastos marinos, las áreas de recuperación o de áreas de humedales artificiales, tiene grandes tasas de acumulación de los carbonos en esas áreas. Pero al mismo tiempo tiene muchas emisiones de metano. Y la balanza es difícil. Hay mucha gente que está trabajando en este. Hay un capítulo en IPCC sobre ese subjecto. En el año que viene vamos a comenzar este proyecto también. Yo no, pero otra gente que está trabajando con nosotros. Muy buena pregunta.
Igual en español. ¿Ustedes están buscando establecer más sitios de monitoreo de lo que están haciendo en Siancán en otras partes de México o solo lo van a restringir a Siancán?
No, yo creo que es muy importante para establecer más parcelas en otra parte de México. Como los áreas yo tengo más interés es como la encrucijada en Chiapas, áreas como Pantanos La Centla en Tabasco, áreas como Campeche, porque esto es el estado con la mayoría de los manglares. Y tal vez, y estos son bancos de carbón, los bancos de carbón más altos en el país también. Realmente la mayoría de los manglares está en Yucatán, pero también esto probablemente es los manglares con la menos productividad de otros lugares cuando hay muchos ríos y los nutrientes sobre los ríos, con los ríos también.
¿Y pretenden utilizar, aparte de mediciones en campo, alguna otra metodología como percepción remota o algunos mapeos con las aproximaciones que hagan en campo o solo...?
Sí, la metodología, yo explico aquí, yo creo es bueno para todo el país, para un inventario de manglares en el país de México. Es muy flexible, muy bueno para manglares bajos hasta los manglares altos y también una otra metodología para los chaparros. Y esto es mi recomendación, es usar una metodología como esto. Y yo tengo un libro sobre este tiempo y hay varias metodologías de medir los manglares, también todas las ecuaciones alemétricas en el mundo está dentro de este libro, el mundo que yo puedo encontrar en la literatura. Tal vez hay otros en México.
Datos sobre esto. Precisamente nosotros siempre intentamos que el trabajo de cooperación se pueda hacer a largo plazo. Hay veces que lo logramos un año y ya no pasa nada. Hay experiencias como el propio sistema de puntos de calor que caminó solo y tiene ya una ruta completamente independiente. Tenemos una experiencia de trabajo con el servicio forestal, un órgano que se llama Aplicaciones Ecológicas de Fuego, el servicio forestal también en la Universidad de Washington, donde después de 7 años de trabajo con un proyecto que se llama Fotoseries, logramos que esa metodología la adaptara la Universidad de Guadalajara, el Centro Universitario Sur, y ahora es la metodología que está incorporada al Inventario Nacional Forestal para la determinación de combustibles. Este es un caso muy exitoso y donde fue posible sostener no solo el marco de la cooperación, sino los dineros, que bueno, finalmente cuesta, a lo largo de un periodo largo de tiempo. Y entonces, me parece a mí que la gran ventaja es que hubo un grupo nacional de científicos conectados con las cuestiones prácticas que generaron este resultado. Y yo creo que es un muy buen ejemplo. La pregunta que acaban de hacer sobre si en otras partes se buscaría trabajar, sí, estuvimos en la mañana en la Comisión Nacional de Áreas Naturales Protegidas y nos hicieron la misma pregunta, varias gentes que trabajan en distintas áreas protegidas, y nosotros decimos, pues estamos motivados con ello. También platicando con Boone, estamos en la posibilidad de tener la solicitud de una torre de flujo que esté ubicada en manglares. Entonces, el intento lo vamos a trabajar. Sin embargo, bueno, el próximo año empieza a haber una serie de cambios en las actividades gubernamentales, pero nosotros como organización civil sí podemos darle seguimiento a estas iniciativas, particularmente cuando están asociadas a organizaciones como la CONABIO o como el CICI, o que sabemos que ahí van a estar, y que esto permite el flujo de actividades y la obtención de resultados significativos.
I think that what she was asking, like the other half of her question, had to do with, I don't know if this is what Eben does, but if you could relate what you do in the field when you're calculating biomass, and if you could relate it to satellite imagery and do it remotely. Is that what Eben is doing?
Well, somewhat. A lot of it is, the question is, how do we scale up? You know, once we have the plots, you know, and really one scales up the same way you'd scale up with a forest inventory in the uplands, you know, and again, in our case, in manglares here, I would stratify by the ecosystem type and get, you know, the range and variation, or develop an equation of cover with carbon stocks within the type, and then just use remote sensing and GIS to develop landscape scale carbon stocks. And this is what's going to be needed for RED at the country or regional scale. ¿Me entiendes? Disculpe. You probably know that. You could answer that question better than I can. You know?
I would like to be a little bit more straightforward. Given, for example, we could provide you an annual cover change based on a quite accurate baseline of the mangrove extent here. We could provide you with quite a good idea of the physical certification of the mangrove. And you got your plots, and we got additional plots here in the country from various groups. Alma, for example, is working with one group in Bancos. So, how much more would be needed to exactly establish something which would be tied to Tier 3 enabled RED MRV reporting?
You know, I think that, again, as far as I know, and I'm probably wrong.
Because I guess we can get the funding.
Right, yeah, right. You know, you need, you know, a CONAFOR-like effort for establishing these forest inventories in mangroves. And, you know, I don't think it would take that much. I think you're right. I think that in a year or two, you know, this is, yeah.
From you, for example, how much plots we would actually need to establish. And I really like your transect right here. I mean, for remote sensing driven analysis, it's much better than the plots we've now in the inventory. So if we could establish that with CONAFOR, and I think it's not really, it wouldn't be really difficult to convince them. They're waiting for something like that. So if we could get an estimate where we would need to sample, how frequently we would need to sample, and how much it would cost. It would be a huge step, and we could be implementing that in quite a short time.
Yeah. No, that's very, very doable. You know, it's not uncommon to see that the science of remote sensing is ahead of the necessary field data to calibrate or to scale up. You know, that's common throughout the world. It's very common in the mangroves of the world everywhere. You know, yeah, again, you know, it's like the cost per plot would be no more than, maybe a little bit more of the initial plot, because you need to get more soil data than most forest inventories are doing. But the field cost would be no more than a forest inventory plot. You know, the density of plots would be no more than upland plots. You know?
Yeah, not so much concerned about the cost actually.
Right.
Because it will be a fraction of the actual inventory.
Well, it's absolutely necessary if Mexico is going to participate in RED, and you look at the ecosystem services, the values that come from the mangroves, you know, it'd be highly recommended. It's very obvious that they should be part of a REDD inventory or part of a REDD strategy, and it's part of the cost of establishing the baseline, part of the cost of participating in REDD. So it shouldn't be too much.
I'm going to be more direct even. If we give you a mangrove extent, the actual mangrove extent 2005, could you give us an estimate where we need to establish how many plots?
Yeah.
Any numbers?
Yeah.
Okay. Then.
We could.
Sorry for being so complicated. I thought my first question was.
Well, you notice I didn't want to answer that either. So.
Bueno, pues le damos las gracias al doctor Kauffman.
Gracias.